Somewhere in a neighboring galaxy, there is a star so bright, so violent, and so massive that it is tearing itself apart just by existing. It shines with the light of 9 million suns. It is so powerful that its own radiation is ripping matter off its surface and hurling it into space. And one day, it will die in an explosion so massive it could outshine its entire galaxy. This is R136A1, the brightest star ever discovered. R136A1 sits inside a dense star cluster called R136. Located in the Large Magellanic Cloud, a small companion galaxy roughly 160,000 light-years from Earth. At first glance, it looks like just another bright point of light in a crowded stellar nursery. But when astronomers finally measured its true output, the numbers didn't make sense. This single star produces almost 9 million times more light than our Sun. If you replaced our Sun with R136A1, the sky wouldn't just get brighter, it would become lethal, instantly scorching every planet in the solar system. But brightness is only part of the story. R136A1 is also one of the most massive stars ever found, packing in more than 200 times the mass of our Sun into a single object. Most stars, including our own Sun, will spend billions of years quietly fusing hydrogen into helium. R136A1 is burning through its fuel so violently and so quickly that scientists estimate it may live for only a few million years total. A cosmic blink of an eye compared to our Sun's 10 billion-year lifespan. That extreme power comes at a cost. Stars this massive generate radiation pressure so intense that it pushes back against their own gravity, blasting streams of stellar material out into space in what astronomers call stellar winds. R136A1 is losing mass at a staggering rate, shedding material equivalent to the mass of Earth every few months. Around the star, this constant outflow has begun sculpting the surrounding nebula, carving out massive bubbles of gas and dust that stretch for trillions of miles. For years, astronomers assumed stars couldn't grow much bigger than around 150 times the mass of the Sun, because the outward pressure of radiation should theoretically prevent them from forming at all. R136A1 broke that assumption completely. Its existence forced scientists to rethink the physics of how the most massive stars in the universe are born. Some researchers believe R136A1 may not have formed as a single star at all, but could be the result of two massive stars merging together, combining their mass into one superluminous object. Astronomers first identified R136A1 back in the 1960s, but for decades, they had no idea just how extreme it really was. Early telescopes simply weren't powerful enough to separate it from the dense swarm of other massive stars packed into the same cluster. It wasn't until observatories like the Hubble Space Telescope and later ground-based instruments with adaptive optics were able to zoom in close enough that astronomers finally resolved R136A1 as an individual star and began to understand its true scale. To understand just how strange R136A1 really is, it helps to compare it to something familiar. If you shrank the Sun down to the size of a basketball, R136A1, scaled proportionally, would be larger than a small car, and it would be burning with the intensity of millions of basketballs worth of sunlight all at once. Its surface temperature reaches over 50,000 degrees Kelvin, roughly 9 times hotter than the surface of our Sun. And its story isn't over. Stars this massive typically end their lives in one of the most extreme events in the universe, a hypernova, or possibly even a pair instability supernova, where the star's core becomes so hot that it starts producing matter and antimatter particles, triggering a runaway reaction that blows the entire star apart, leaving nothing behind, not even a black hole. If R136A1 ends its life this way, the explosion could briefly outshine its entire host galaxy. Visible across intergalactic distances, a cosmic event so energetic that telescopes on Earth could detect it billions of light-years away, long after the star itself has ceased to exist. Stars like R136A1 also matter because of what they leave behind. Massive stars are the universe's element factories. Every time a star like this fuses heavier elements in its core and eventually explodes, it seeds the surrounding galaxy with heavy elements, carbon, oxygen, iron, and more. The very same building blocks that would later go on to form planets, oceans, and eventually, life. Stars like R136A1 remind us that the universe doesn't just contain calm, stable suns quietly warming their planets for billions of years. It also contains monsters, stars living right at the edge of what physics allows, burning so violently that their own light becomes a weapon against themselves. Somewhere out there, right now, R136A1 continues to blaze, shedding mass, warping the nebula around it, counting down toward an ending that will be almost impossible to ignore. But this is only the beginning. The universe still holds far greater mysteries, stars and objects we haven't even discovered yet, some possibly even brighter, even stranger, even more extreme. What scientists find next could completely rewrite what we think we know about the limits of the cosmos. If you want to be there when it happens, hit subscribe and join us as we keep exploring the most extreme corners of the universe.